joining us to unpack this fascinating breakthrough and a little bit scary because it sounds like it's something out of a Jurassic Park movie, is Dr. Victoria Sugrue, who is part of the epigenetics lab team at Otago University. Well, good morning, Victoria. Great to have you on the show today. And first of all, how are you feeling about this?
I think it's kind of amazing what they've managed to do with this tech, but also kind of crazy and maybe a little bit scary. And we're all thinking
Yeah.
the Jurassic Park situation. So yeah, there is a lot to unpack, like you say.
Okay. So basically, a prehistoric wolf that went extinct is now back to life. Or is there more to it? So let's just talk about what's actually going on here in layman's terms. Break it down for us who perhaps don't understand the epigenetics like yourself.
Yeah. So um, basically, what Colossal have done here is they have used these really sophisticated genetic engineering techniques to take a grey wolf, which is a modern species that exists right now, and they've made some of their existing genes a little bit more direwolf-like. They've just made some really small little edits. Um, these edits actually only affected 14 genes, genes that affect the wolf's appearance, so things like body size, the face shape, and the coat color, of course. But they didn't build these wolves from the ground up. They've taken an existing grey wolf, made a few little tweaks to make it look a little bit and sound a little bit like a dire wolf. But essentially, what they've done is they've made a kind of grey wolf that kind of looks dire wolf-like. I sort
Okay.
of think of it like a grey wolf is kind of wearing a dire wolf costume.
Right. So they've made a monster sized normal wolf, but changed the color to white, basically.
Yeah, they've just played around with some of these appearance genes. So
Okay.
it
Well,
looks like a dire wolf,
that can
but
sound a little bit risky, right? Because I guess if you're playing around with the recipe for, let's say, a cake, you never know how one ingredient is going to affect the other ingredient. So let's talk about the pros and cons of using this technology because they're obviously trying to achieve a few things. I mean, in the conservation space, for one, they're trying to see, why animals go extinct in the first place. But what are some of the hazards to doing this?
yeah. So from a geneticist perspective, we do need to consider the fact that these genes can have a lot of different functions, and they can be involved in a whole lot of really complex biological networks. So just because we're targeting a gene that might change the coat color doesn't mean that that gene doesn't have these other roles and things that might be really important for the animal's health. So by editing it a little bit, we might be creating an animal that is going to get really sick and is going to suffer. So we need to consider these unintended consequences for the welfare of the animals and the wider ecosystem.
Well, I think you see that when you do your own form of sort of genetic selection, when you are breeding, let's say, dogs. For example, I think of the miniature pug, right? Like they've been bred so much to have these characteristics of like a smushed face, but actually it's actually quite inhumane in many ways because these poor dogs struggle to breathe. Their lifespan's pretty short. They have all these allergies and they're constantly at the vet needing surgeries. So, yeah, you've got to think of the animal's welfare. And I guess you've got to think too, what could happen if the technology got into the wrong hands as well? Like, what are some of the risks there?
That is such a fundamental kind of moral question. I would like to think that tech like this is going to be highly regulated, or that people will use it for good. But we don't know people's intentions. But yeah, I've been thinking about this stuff, and I'm kind of hoping that we will use this stuff maybe to focus a little bit more on the conservation stuff and preserving these really threatened species we currently have, which I think is a lot more important than bringing back these prehistoric species that there may not really be a niche for in the
Yeah,
environment anymore.
that's an interesting perspective. And I guess if we're speaking of pros and perhaps
Mm.
looking at New Zealand and our flora and fauna, what's the likelihood of scientists in New Zealand, let's say, trying similar technology to bring back, let's say, an oversized bird or two like the moa or the Haast eagle?
That is such an interesting question. I certainly do not know of anybody who is considering that kind of stuff. But yeah, so the moa went extinct only about a few hundred years ago, which is a lot less than 10,000 for these wolves. But that doesn't necessarily mean that it's going to be way more easy to find a good genetic code that we can base the sort of work on. Um, so the DNA is going to break down over time, and the environment that these bones are in are going to play a massive role in how fast that happens. So DNA that's been purified from moa bones currently is it's really bad quality. It's really fragmented into these really small bits, and makes it really hard to read.
So, like, best case scenario, if we had a go at it, we'd get like a plump kiwi, an oversized kiwi, if we were lucky.
Maybe we would need this kind of similar bird. It's a ratite bird to edit that, like they have with the grey wolves. So maybe it would be kiwi. I highly doubt it. I highly doubt that anyone in New Zealand would be okay with us meddling with the kiwi genome for something as crazy as this.
Yeah.
But maybe for the conservation, maybe.
Yeah. So it's a maybe, but it's definitely not a likely on the cards for New Zealand when it
I don't
comes
see
to.
it happening. I don't see it happening. No.
Okay. Well, thank you so much, Dr. Victoria Sugrue, part of the epigenetics lab team at the Otago University. Thank you so much for sharing some thoughts on this.
Having me.
Amazing. I hope you enjoyed that as much as we did.
Yeah, don't forget to like and subscribe and turn your notifications on so you don't miss the next video.
We'll see you in the next one.